All right, this is lesson 9.3 on differentiation, A-level pure maths, year 2. In this lesson, we are going to learn how to use the chain rule of differentiation. Suppose you've got y equals to 2x squared minus 3x, all of that squared, to differentiate. Anyone who doesn't know the chain rule will expand this first to get y is equals to 4x to the power 4 minus 12x cubed plus 9x squared, and then differentiate each of the three terms individually to get dy dx is equals to 16x cubed for this minus 36x squared for that, and 18x for this one. I could also say let u is equals to 2x squared minus 3x, which is a function within a bracket. So in this case, y will be equals to u squared, because we said u is what is inside the bracket. Then I'll differentiate u with respect to x to get du dx is equal to 4x minus 3. And then differentiate y with respect to u to get dy du is equal to 2u. Then I'll use this formula. Dy dx is equals to dy du times du dx. So you can see that 2u will replace dy du over here, and 4x minus 3 will replace du dx. So let's do that substitution, and we get the following. But I know that u is equals to 2x squared minus 3x. So if I do that substitution, then I end up with dy dx is equal to 2 times 2x squared minus 3x times 4x minus 3. And that's my differentiation of this. Now let's simplify this and see if it's the same as that. So first of all, I'll expand 2 into this bracket to get 4x squared minus 6x times 4x minus 3. Then I'll expand the two brackets to get 16x cubed minus 12x squared minus 24x squared plus 18x. Minus 12x squared minus 24x squared are like terms. So if you combine them, we end up with dy dx is equals to 16x cubed minus 3x squared plus 18x, which is the same as that. So this formula here, dy dx equal to dy du times du dx is what it's known as the chain rule. So what's the point of using the chain rule when we could have just expanded this and then differentiated the individual terms like we did here? Two reasons. The first one is, what if the power is not 2 but 5, like this one, or even 10? With this one, you will have to expand this using binomial expansion to get 6 terms and then differentiate each of the individual 6 terms. And that's why we need to know the chain rule. Now, this kind of function is also sometimes referred to as a function of a function, because there are two functions within this function. The first function is this outer one here, 2x squared minus 3x raised to the power 5. And the second function is the one contained in the bracket. Because of the nature of this function, that's why sometimes this type of function is referred to as a function of a function. Now, we use the chain rule to differentiate a function of a function. And this leads me to the second reason. The second reason is this. You don't have to go through all this process. We could have just started from here and end up with this one without going through all this process. And that means we do this process here mentally. And so we move from here to the derivative over here. And I'm going to show you how to do that. So first, I'll show you how to do that. And then I'll go back and solve the same question using the same process. So dy dx will be given by, I'll bring down 5 to multiply the function and reduce the power by 1. So I have 5 times 2 x squared minus 3x to the power 4. And just to remind myself that I need to differentiate what is inside the brackets, I'll just say dx of 2x squared minus 3x. They're just saying that I need to differentiate that. Then I'll proceed and do this. So this will be equals to 5 times 2x squared minus 3x to the power 4. Then when I differentiate this, I'll get 4x minus 3. Then I'll write it nicely as 5 brackets 4x minus 3 times 2x squared minus 3x, all of that to the power 4. And that's the answer without using the whole process. So I did all this process mentally. Now let me go and use the process to do the same question to see if we get the same answer. So I'll let u equals to 2x squared minus 3x. That means du dx is equals to 4x minus 3. But y we know will be y equals to u, which is this, to the power 5. Then dy du will be equals to 5u to the power 4. But the formula says dy dx will be equals to dy du times du dx. And so dy du is 5u to the power 4, and du dx is 4x minus 3. So dy dx will be equals to 5u to the power 4 times 4x minus 3. Then I know the value of u, so I'll substitute that to get 5 brackets 2x squared minus 3x times 4x minus 3. Then write it in nicely. I'm going to get 4x minus 3 times 2x squared minus 3x to the power 4. There should be a 4 here. And so we get the same answer as the short way of doing it mentally. So it's advisable to learn how to do it this way, because sometimes you have to do the chain rule twice within one question. We'll see some examples soon. So in general, if y is equals to this function raised to the power n, then dy dx will be n times the function, reduce the power n by 1 to get the following, and then differentiate the function inside the brackets to get this. And simplifying will give you this. Or if f is equals to this function, then dy dx will be differentiate the whole function, which will give you this, and then multiply that by the derivative of what is inside the bracket. That will give you this, and then when you simplify it, you get this. So that is the chain rule of differentiation. We are now going to answer a few more questions using the process and also doing it mentally to give you some practice. It's advisable to pause the video, try it yourself, and then move on. So the first one, I've got y is equal to 6 over the square root of 4 minus 5x. First, I'll need to rewrite this one appropriately like that. And then let u equals to 4 minus 5x. That means y equals to 6u raised to the power minus half. Then I'll differentiate u with respect to x, and I'll get du dx as minus 5. And differentiate y with respect to u, and I'll get minus 3u raised to the power minus 3 over 2. And then I'll use the quotient rule. That means minus 3u raised to the power 3 over 2 replaces dy du, and then minus 5 replaces du dx. So let's do the substitution, and I'll get that. Minus 3 times minus 5 is 15, so that will simplify to 15u to the power minus 3 over 2. But the value of u we know to be 4 minus 5x. So let's do the substitution, and I'll get that. I can write this one as a fraction as follows. So dy dx is equals to 15 over the square root of 4 minus 5x cubed. Now let me try to do this mentally without using this process. So I have y is equal to 6 brackets 4 minus 5x raised to the power minus a half. So dy dx equals to minus half comes down to multiply the 6, and I have minus a half times 6, and multiply by the function, which will be raised to the power minus 3 over 2, because I'll reduce the power by 1. Then to remind myself that I need to differentiate what is in the bracket, I can write this d dx of 4 minus 5x. Then minus half times 6 will be minus 3, and 4 minus 5x raised to the power minus 3 on 2. Then differentiate this, which will be minus 5. Minus 3 times minus 5 is 15. So I have 15, 4 minus 5x, all of that raised to the power minus 3 on 2. And this is the same as 15 over 4 minus 5x raised to the power 3 on 2, which is the same as 15 over square root of 4 minus 5x all cubed. And so that's the short way of doing it. Question 2. So we are going to use these standard derivatives over here for some of the questions that will follow. And for this second one, we're going to use this derivative here, sine. But first, I need to rewrite this as follows. Y is equal to the cube of sine x, which is the same as this. And then let u equals to sine x. And that implies that y will be equals to u cubed. Then I'll differentiate u with respect to x to get du dx is equals to cos x, as shown here. And then differentiate y with respect to u to get dy du is equals to 3u squared. Then I'll substitute that into the chain root formula to get 3u squared times cos x, because 3u squared replaces dy du, and cos x replaces du dx. But u is equal to sine x, and so we're going to get dy dx is equals to 3 sine squared x cos x. And that's the final answer. So now let's see how we are going to do that without going through all this process. So I've got y is equals to sine cubed x. So dy dx will be equals to, the 3 comes down to multiply, and we reduce the power by 1. So I'm going to get 3 sine squared x, then d dx of sine x. So now I'll come to get 3 sine squared x. If you differentiate sine x, you get cos x. So times cos x. And that is exactly what we got over here in just 2 steps. That's why it's important to know how to differentiate this using this process here. The next one, I've got y is equal to ln x squared. So in this case, let u equals to ln x, and therefore y will be equal to u squared. So if I differentiate u with respect to x, I'll get du dx is equal to 1 over x, because the differential of ln x is 1 over x. And then dy du is equal to 2u. Then I'm going to use the chain rule formula dy du is 2u, and du dx is 1 over x. So that will give me 2u times 1 over x. But u is equal to ln x. So I'm going to get 2 ln x times 1 over x. And writing this nicely will give you 2 ln x over x. And so let's do this mentally. So I have y is equals to ln x all squared. So dy dx will be equals to the 2 comes down here to multiply and reduce the power by 1. So I get 2 ln x, and then I'll say dx of what is in the brackets, which is ln x. And that will be 2 ln x times, if I differentiate this one here, I'm going to get 1 over x. And so this will be 2 ln x times 1, which is 2 ln x over x. We get the same answer, this time in 3 steps. Question 4. So this time I have y is equal to e to the power cos 4x. So let u equals to cos 4x, and that means y equals to e to the power u. And we can see that we have got chain rule here. So it's going to be a chain rule within a chain rule, because u will be equals to cos 4x. Now, du dx will be the differential of cos 4x times the differential of 4x. So I'll have minus sine 4x d dx of 4x. And that will give me minus sine 4x times 4. And that will be minus 4 sine 4x. And so du dx, we use chain rule to differentiate this whilst we are doing chain rule. And that's why it's very good to do this mentally. And so du dx is minus 4 sine 4x. And then using this standard integral here, dy du will still be e to the power u. Then my chain rule formula says dy dx is equal to dy du times du dx, where dy du will be e to the power u, and du dx will be minus 4 sine 4x. So if we do that as substitution, we're going to get e to the power u times minus 4 sine 4x. But du, we know it to be cos 4x. So let's do the substitution. We're going to get e to the power cos 4x times minus 4 sine 4x. Write this nicely. You're going to get dy dx is equals to minus 4 e cos 4x sine 4x. Now let's try to do this in the short way. So I've got y is equals to e to the power cos 4x. So dy dx will be equals to the differential of e to the power cos 4x will be e to the power cos 4x, as it states here. But we have to differentiate this, so I can write dx of cos 4x. So now I'm going to get e to the power cos 4x. Then if I differentiate this one, it will be times minus sine 4x times the derivative of 4x, because it's also a function of a function. And so now I'm going to get e to the power cos 4x times minus sine 4x times 4, because the derivative for 4x is 4. And then writing this nicely, I'm going to get minus 4 e to the power cos 4x sine 4x. And that's exactly what we got over here. One more question. Y is equal to the sine of e to the power minus 3x. So in this case, we are going to say let u equals to e to the power minus 3x. That means y is equal to sine u. So here, It's another chain rule within chain rule. So I have u is equals to e to the power minus 3x. du dx is equals to, if I differentiate e to the power minus 3x, I'll get e to the power minus 3x. And I need to differentiate minus 3x. So that would be e to the power minus 3x times the differential of minus 3x is minus 3. So I'm going to get minus 3 e to the power minus 3x. And so du dx is minus 3 e to the power minus 3x. And using this standard integral here, dy du will be cos u. And then my chain rule formula will have cos replacing dy du and minus 3 e to the power minus 3x replacing du dx. So we get the following. But u is e to the power minus 3x. So if I do that substitution, I get that. Should I put this in brackets? Like that. Then we're writing this nicely. They're going to get minus 3 e to the power minus 3x cos e to the power 3x. Again, I need to put this in brackets. So let's do this again without going through all this process. So I have y is equals to the sine of e to the power minus 3x. dy dx will be equals to, if you integrate sine of anything, you're going to get cos of that thing. So I'm going to get cos e to the power minus 3x. Then I'll differentiate e to the power minus 3x. So now I have cos e to the power minus 3x times. If I differentiate e to the power anything, I get e to the power of that thing. So I'm going to get e to the power minus 3x. But I need to differentiate that power of minus 3x. So I'm going to get cos e to the power minus 3x times e to the power minus 3x. If I differentiate minus 3x, I get minus 3. So putting everything together nicely, I'm going to get minus 3 e to the power minus 3x cos e to the power minus 3x, which is the same thing that we got over here. And with that, we come to the end of this lesson on chain rule. Thank you for watching. See you in the next video.